Good evening, and thank you for joining me this wonderful Wednesday evening. Please let me know if you can hear me and see me all right in the chat. All right, thank you very much. My name is Catalin Dumitras. I'm the Principal Cloud Architect at Pentalog, and today I have the honor of discussing about an adventure that took me very deep into the rabbit hole of software and hardware. So today's topic is a first in a series of 3 webinars dedicated to a very interesting use case. But before we get into the use case, let's take a small look at the contents for this evening so you know what you can expect. There we go. So first, we're going to talk about why are we doing this with the cloud. This looks very much like a personal project, like something you would host on a Raspberry Pi at home. And we're going to get into that in a second. We're mostly used to talking about software in these webinars, especially when I'm presenting, but today is going to be special. Today I'm going to talk about hardware, and I will kindly ask that anybody who's in the embedded world try not to scream too hard at the screen. One interesting thing that we're going to be discussing is, besides what hardware, what is the requirement for choosing our hardware? Because we're used to dealing, especially as solution architects, we're used to dealing with requirements, especially non-functional requirements. Well, this time we have a very special set of requirements, and choosing a programming language for hardware device is definitely an unexpected research project. Before we get on to the demos, we're going to discuss a little bit about the difficulties we've experienced in the ecosystem, because the ecosystem has progressed very rapidly in the last couple of years and made itself much more available, but unfortunately it's still not as good as it could be. And we have 2 small demos, one involving the software part, the data ingestion part into the cloud, and well, the second is actually I'm gonna show you, we're gonna play a little bit with the real hardware. Hopefully I don't break it. All right, and last but not least, we're going to go into a Q&A session where obviously we're going to have a QR code ready for you, so while I answer your questions, you can also give some feedback on the presentation. All right, so let's talk about the use case. We as software people, we've done a lot of things, from on-premise to containers to serverless to streaming, anything in between. Hybrid cloud, but we rarely go inside the hardware world. We rarely go into that space. It's like we have 2 different silos, maybe one of the last silos that we need to break through. There's the software guys and the embedded guys, or the hardware guys, totally separate, right? Well, I've been having this very vivid desire to try and build something using both hardware and software, and of course, since I'm not gonna do this real-time in production for a client first, I had to find a personal use case, and I thought, what better thing than my car, because it's something I currently share with friends and family, and sometimes I want to see where it is. I want to see how fast it goes. It's just, curiosity. So by merging the 2 together, I thought, let's build something like a tracker for the car, but not just a tracker, because everybody can buy a tracker off the shelf, right? That's easy. You just buy it, you plug it into the OBD port, easy peasy. No, we want something a little bit more fancy, a little bit more interesting, right? Because we're not just gonna be happy with an update every 10 minutes on our position. We really want to find something. For example, for me, safety is very important, and I'm not sure if everybody I loan the car to, it feels the same way. So I want to see how safe I'm driving compared to my friends and family. So I guess that's something that's very unique because, and that's deserving of our attention, because I couldn't find anything to buy on the internet that can give me both the location and the driving style, the driving dynamics of, well, I see driving dynamics. We're not going to the racetrack, but still, I want to see the G-forces, how fast you turn the car, how fast it accelerates, it brakes. And since we're living in a country which might not have the greatest infrastructure in the world, how many potholes we take in a week or a day. So obviously, we're not going to get through all of that in just one webinar, but this first webinar lays the foundation for that let's say platform, that technology. All right, so as I do with every webinar, I first talk a little bit about the cloud. Principal Cloud Architect talks about the cloud, makes sense somewhat. So why do we go with cloud, right? Because usually the cloud allows us to focus on what matters. And in this case, for example, obviously, what matters for me is not if the operating system on a virtual machine in the cloud is up to date or has enough RAM or disk space. For me, what matters is the data that's going to be generated from the car somewhere where I can see it. That's it, right? It allows us to deliver faster. If I can use something off the shelf, if I can plug things in, have the cloud do the heavy lifting, you know, I have more free time to watch Netflix or something else. So obviously at work and at home, the same thing is there. I'm not going to want to do firewalls, port forwarding, Raspberry Pi installations, dynamic DNS. No, I want something easy, low maintenance, and something that helps me save time. And this is going to sound weird, because usually when you say about saving time, you think I'm going to go into the console and I'm going to set things up. I'm just going to start next, finish. But that's not exactly what I'm going to do. So even in this personal project, we're still working with automation and abstraction, because believe it or not, sometimes it might be actually easier to use a programming language than to use the console. Sometimes. The user experience of cloud providers is usually very good, but it has its exceptions. And in this case, especially with IoT, I think infrastructure as code helps us quite a bit. So abstraction and automation. We abstract the things that we don't care about, and we automate the things we do care about, so it's easier to use. In this webinar, we're going to go with AWS. But before we go on to AWS, this is the chart I show every time, and I want it fresh in everybody's memory, because this is going to show you what kind of services we're going to use today, right? So we started in the on-premise world long time ago, when it was the 90s or something. Everybody had a server in the office. Then we moved over to the start of the cloud, infrastructure as a service, where we started not to manage the storage, the hardware, and the network. That became something very far away from our attention. Moving forward, we went to platform as a service. Think Heroku, Elastic Beanstalk, so on and so forth, where we started not to care about the operating system and the database at all, right? The cloud provider manages that for us. We care about the runtime, so our version of Python, PHP, Java, etc., and the application code itself. And now serverless, the runtime is also being abstracted away by the cloud provider. And let's say maybe an asterisk beyond serverless would be SaaS. We just use that specific service, and we don't care about managing anything else. So right now, what we're going to use today is going to be a mix between serverless and SaaS. Maybe have just one Lambda function, and the rest is, in a way, between the definition of serverless and SaaS. Okay, so let's go with why AWS. We have 3 major cloud providers. They've been doing great things in the pandemic. They've been launching a lot of features. So AWS, GCP, and Azure. GCP and Azure have been adding at a greater pace than the last, let's say, before the pandemic. They've definitely upped their game, but there's still, this is a slightly older picture, but they still haven't caught up to AWS. And the reason why I've chosen this cloud provider for this webinar this evening is that it still has the most features, especially in the IT part. It still has a lot more features and a lot more integrations, which is going to allow me to, as I said, code as little as possible and watch a movie in my spare time extra than maybe if I went to the other cloud providers. All right, so let's start a bit with the cloud architecture. I'm gonna switch over to draw.io because it is a vector and it's always going to be much better than anything that's going to be in PowerPoint. There we go. So this is quite a simple diagram for such a complex project. So we're going to start off with the car. So this little beautiful thing is our IoT device, and we're going to get to how that looks and what's in it in just a second. But this is our IoT device. It's going to be pushing data over MQTT, and it can also push over HTTPS, but usually on IoT applications, we push over MQTT because it's both a binary protocol, which usually takes less bandwidth, and bandwidth is important, but also because it has quality of service features. So that means that we can say if a message is important and should be delivered at least once or at most once. So, well, not at most, but it's not as important that we continuously try to resend it until we receive confirmation that it has been sent. So it has some features there. The service that's gonna receive our data is called IoT Core. And this AWS has a lot of IoT services. All you have to do is enter on their page, and you can see it has like 7, 8. There's a lot of things. But for us right now, all we're interested is IoT Core. And we will be using IoT Core to send data to 2 databases, time stream and location. Let's talk about time stream just for a second. Time stream is a time series database. You usually find this used a lot in financial applications, in, let's say, analytics, but it also works really, really well in IoT because it allows us to do all kinds of window-based analytics. And we can say, for example, in our case, we can say, why don't we try and figure out the average speed over, let's say, a day or a week, right? If, for example, you have multiple drivers, you can see, let's say, in the days that driver 1 has, used the car, the average speed is hopefully not 100 kilometers per hour, less, right? Driver 2 has so on and so forth. So that might be really, really interesting. But what also allows us to do is to use analytics functions to detect, for example, breaks in behavior. So, for example, if we send data with a resolution of a couple of seconds, right? So that means that we're driving. We're sitting on the stoplight. Let's say we do this sort of improvement that maybe we won't be sending data while we're standing still because there's not really much going on. But I mean, in theory, once the car stops, you might want to stop sending the data. Or let's say if you're standing still in the parking lot eating at McDonald's or something, it's not a trip, right? You had 2 segments of trips. So instead of having buttons and saying driver 1, or sorry, start trip, end trip, by detecting gaps with a few SQL queries, you can basically separate the trips automatically, right? So no fancy AI, no nothing. It's just simple features that we can use for SQL. So that works pretty well for us. Second, it's a serverless database. It has some particularities in the way that the billing works, but you can really get away with not paying a lot of money. So that's why we're using something like this and definitely not something like RDS or Aurora with MySQL or Postgres, or we're not using anything like DynamoDB, because that would be such a painful thing to try and model. Imagine trying to load data from a NoSQL database and then processing everything, trying to find breaks and driving. That would be very, very painful. And the second is AWS Location, which is actually the service that has been built by AWS for exactly this purpose. It provides with mapping functionality. So that means that we'll be able to use maps, not Google Maps, so Here Maps, all kinds of other sources, even satellite views, to display our data. That is very important because you can choose, you have a lot more flexibility. Even the rendering part is based on an open source project from Mapbox. So that's pretty good. As some of the most important features I would note is being able to have to search for locations, so like geocoding, store specific locations in a database, have multiple databases of asset tracking. So for example, if you have a fleet of taxis or a fleet of rental cars, you could have different databases based on location, for example, or geographies. Of course, it has the history of all the previous data of each car. So I think that in essence, what I meant to say is geofencing. Instead of having you build a database and a feature to try and detect if, let's say, car one has exited the geofence, which for example might be the town you're living in or the country, for example, especially for businesses which are renting cars. That's very, very important. They want to know if somebody has left the geography. You just basically upload a list of polygons where you want that geofence to be, and you receive an event notification that you can then act on SMS, email, or something else, even an API, all without you having to really write code. Well, you have to write the event handler, so that's normal. I mentioned the event. The event goes through EventBridge. It's the de facto service in AWS for sending almost any kinds of events, cloud-native events, that is. Why is this not showing? Let me put this here. So we have Lambda, our one and only serverless function for now in step one. It basically works with one or another of these services to fetch historical data and then to send it via an API gateway, a REST API gateway to us and our browser. Basically, we want to see the data. We have a very dumb interface for now for the demo today. All right. Obviously, now we have a website that we want to, our dashboard that we want to look data, visualize things on, like locations and stuff. We're not going to start a server or a container for that. We're just going to use a single page application, React-based, with Amplify, which is the de facto AWS, let's say, framework or library, better said, that allows you to use and work with AWS services in a much more streamlined and easy way than working with the SDK itself. The SDK is humongous. Since it has so many features and services, obviously you're going to have a million API calls, and it's going to be, flexibility comes with complexity. Therefore, we needed something that allows us to streamline operations for the most common use cases, and Amplify is that thing. So this React application will be storing in S3 with CloudFront as the CDN. The CDN is mostly used because it's, it has it's forward proofing than just storing out a S3 static website. You notice here there is no CI/CD. This is a somewhat more hobbyist project, so there isn't one. That doesn't mean that we upload things manually. No, that's not how it is. We still have a deployment step with CDK, but it is a much more streamlined. It's not meant to necessarily run on CI/CD platform. So why is this Cognito in here? Do we have username and passwords? Not in step one, but for example, to work with certain things in AWS, you still need some sort of, let's say, unauthenticated session, right? So that means it has to be protected. And in this case, the Cognito identity pool does that for us. It allows us to give token-based permissions to unauthenticated users for certain actions. This is actually required, and we'll show you where it was configured and how that was in a second. I should be doing a little bit better and moving faster. Sorry, there's a lot of things to cover. So just as a notice for the data flow, data is coming from the device, it goes into IoT core. There's an IoT rule basically that says data coming from this topic goes into these two databases and then goes up to the client. In the case that in the future where we will have the geofencing capability, if it detects that the location is outside the polygon that we have uploaded or defined, an event bridge event is fired that goes to SNS, and SNS can, do whatever from Slack, Teams, SMS, email, etc., etc. So that's basically the data flow for us. I'm going to stop. Let's see. I'm going to stop sharing my screen, and we can go to the next slides. I'm going to go as fast as possible without losing too much detail. I really hope you can see, you've seen the right slides. No, just observe data. So there was a question there that was just observe data. No other types of models. So stop sharing, and I'm sharing the presentation again. Oh, okay, so what hardware? The software part was more or less what you'd expect from this sort of presentation, right? We're into cloud, we use cloud stuff. We went full, full in. We've let the cloud offload as much as possible. But what about the hardware, right? This is the tricky part. What are we going to use? There's a million different tutorials out there and a million types of devices, from very expensive, thousands of dollars in development kits, to $10, $20. There are GPS modules out there for $7. You have to put your own wires and solder to some ESP86. That's again a couple of dollars. So I mean, that sounds very complicated. But from all of my research, there are two companies which usually try and give people a little bit more help in starting. Of course, the price is, slightly larger. There's one company that's going to be popping up in almost any tutorial out there, Adafruit, and they have a lot of boards. And what's nice about these type of boards is that instead of having, I'm not sure if you can see, to use connections such as this that you solder yourself, or some sort of cables like this, you get to use some sort, you basically have a standard interface between all of them. And I'm going to try and show you one. So this is called, this is not a quick cable. This is a slightly bigger variation. This is JST PH or SH. There's two variations, one smaller, one bigger. And they have connections between themselves. So this is what is called a quick cable. This is from a very similar standard, but Adafruit has both quick and got Stemma QT and Stemma QT. So they're very, very similar, but it's a standard. It's plug and play. So for example, I'll show you this wonderful device from them This is actually, that's going to go on into a future part. This is, well, no, this is a speaker module. And this speaker module can be used only by plugging things into this port. And this port provides both data and power. And you don't have to solder anything. Everything should work by itself. There's libraries for it, which is very nice. Both companies have this, put a lot of effort into supporting the developer ecosystem. And you might wonder, why would I need a speaker? Well, if it's a driving analyzer or profiling of your driving skills, if you're gonna be taking that that curb way too fast, well, you want feedback very close. So you might want to play a short teriyaki drift MP3 or something, or maybe slow down Buster or something like that, to give some feedback to the driver. So that's one of the fun things that's going to come up. So the Adafruit has a lot of boards. There's many, there's too many to do feathers and all kinds of boards that have many configurations. The second one is SparkFun, which is, again, an American company. It has basically the same idea, but they go a little bit more feature rich, I would say. They have a very big amount of development boards as well, with AI stuff, Bluetooth, Wi-Fi. These are kind of like in the premium hobbies sector. Anything else usually comes from very big manufacturers, and it's over $500. So this is what we restricted our let's say our range of options from these two companies. Now let's talk a little bit about the requirements for hardware. Let's see how much time we have left. Well, let's hope it's enough. So with software, we discuss about high availability. We talk about technical debt. We talk about a bunch of things like performance, scalability. But in the hardware world, we have to deal with real life things. This somewhat blurry picture is from the Middle East, where, granted, it's a bit more hot than it is in Eastern Europe, but it shows us how the dash is melting, right? So any device you build for the car has to, well, survive in that element. And there's very interesting standards for a car, and it's based on, for building something for a car, it's based on where you plan on plugging it in. For example, in the engine bay, well, that's the furnace. So that area has such hard standards that I wouldn't even consider building something for that, because it's supposed to, I think my solder, if I'm going to solder something, is going to basically melt in the high degree of the summer. So that's out of the question. So obviously it's going to be installed inside the box where the humans live, where the humans stay in the car. Then let's talk about power. Obviously, not a lot of cars have sockets that have alternating current. Most of them have, especially older cars, have nothing. You have to plug in yourself into some fuse boxes. And that's where we talk about other requirements, such as being able to convert and survive electric, voltage spikes. When you turn on your car, there's somewhat a significant amount of voltage coming in through those ports. So sometimes it can be 50, 60 volts, even if it's supposed to be a 12-volt car. We're not talking about 24-volt systems. So it's going to be fairly robust. For us, in the first step, because that would have been a little bit too complicated, we've went through an external power source, basically a battery, which is a run-of-the-mill USB-C type power brick. That's the easiest thing to start with, and that's what I would recommend. What I would not recommend is leaving that brick in the sun again, because it's not gonna be a happy experience. That can catch fire. And we do have a few modules that we're testing for converting 12 volt into basically USB power. So that's going to be interesting. Let's talk a little bit, just 1 minute, about our choice of hardware, what we ended up choosing. So this is the Spark Fun Asset Tracker. And this little thing is it is perfect for our use case. It comes with this little thing, this white thing. This is basically SARA R5. This is a chip that provides both LTE-M, so IoT specific, and GNSS. So it's GPS, GLONASS, all the stuff, right? All of the satellites. And you'll notice here that there is a hologram SIM. That's very important. This hologram is a company that actually provides you with SIMs that work pretty much all over the world and can transmit data. Of course, there's different pricing models available depending on your geography, but it's something you might not know. For example, in Romania, we have two big IoT LTE networks. This is well, I'm not going to say names, but you might, when you think about stuff like this, you might be thinking of some other company which provides very, very cheap, let's say, phone plans, which are like €2 per month. Unfortunately, that's a different type of network than our needs. So again, it's very specific. LTE-M, we can't use anything. We can't use any network. It has to be a very specific one. And you'll notice here, this little thing, this is actually a special type of board that we can plug in here. This is actually just the baseboard, and I have it here. I'm going to show it to you right now. This is the, let's say, the proof of concept. This is how it looks in real life. And you see here that this is lacking the processor. The processor is separately bought. This is the micro mode. Let's see, because I keep forgetting the name. The Asset Tracker Update Tool. This is basically a special type of chip which allows you to connect via USB and a special software from uBlock that allows you to see the connectivity and to do all kinds of settings on this white chip. And that's very important. Now, why have we chosen this, right? We talked about LTE-M. We talked about the GPS receiver, which is really, really good. It's an M8. Usually the ones you buy with $7 are really, really bad, like M4 or something. It's very bad. Well, it's not very bad. It's what you're paying for. It has an inertial measurement unit, very important for where, we're trying to take that corner G-forces, a digital microphone, an SD card, a LiPo battery charger. This is something for, again, this does not fit our requirements because we can't use LiPo batteries because it's really, really hot in a car. What we could have used is LiFePoE 4, but unfortunately, this microchip does not support LiFePoE 4. So that's something we have to move away from. Separate connections, which is good. 3.3 power for an active GPS antenna. This type of antenna is extremely, let's say, well, it has an amplifier. And that means we need to power it with 3.3 volts. So that works really well. Quick connectors, a few indicators, and a battery for a real-time clock. So what we really were interested is having that GPS and let's see, that LTE connection, our inertial measuring unit. So basically our gyroscope and our G-force meter. And of course, what we really wanted is to also have quick, because this is what we're going to use to basically connect these two things, right? The modules such as the speaker and our main IoT board. All right. One of the reasons we also chose this is that it was kind of like an all-in-one package almost, right? The main functionality is delivered by a single board, and we have a ton of examples. Granted, they're all in Arduino, so that's more C++ type, but you know, we decided, well, let's take a gamble and maybe we can cheat. This is how one of the schematics looks for it. So I'm not going to pretend I understand exactly everything on this, although it is a very pretty picture. It can also serve as a modern art masterpiece. So it has a lot of features. That's really nice. Let's talk about our choice of programming languages real quick. Yeah, we still have a little bit of time left. So by default, this comes with libraries and supported. So libraries specifically for the GPS chip, which we have over here, and the board itself, which is a separate type of package, a different library. All of them in Arduino with example codes, and I'll show you that in a second. We said we can cheat a little bit, and we wanted to use Python, obviously, because we have a little bit more power than the standard GPS tracker out there, which is extremely low power. So it doesn't have almost any memory. It doesn't have almost any processing power. What we did go with is 2 processors. We have 2 processors just in case we encountered any issues, because these are hardware, right? We can't just install stuff over the internet. We have to buy something, it gets shipped. It's a very long lead time, so might as well get something out there in advance. So we have the SAMD51 processor, pretty powerful. You know, it's not as powerful as a Raspberry Pi, of course. It's nothing like that, but it's a far cry from, you know, those really tiny microchips that you could, you know, let's say you can barely write any code on. And the second one is an RP2040. It's basically the new small form factor Raspberry Pi processor for you know, IoT stuff, for small development boards. So this is our backup plan, right? And why did we go for CircuitPython? The CircuitPython has, besides allowing us to use Python, it comes with a very easy development experience. With all of the other tools out there, platforms, you have to write in a special editor, you have to you know, compile it and build it and deploy it, whatever. Sometimes that's easier, sometimes it's harder. With CircuitPython, it's you have a drive when you plug in the device over USB, and then you drag and drop your files over there, and that's your deployment right there. That's it, right? So that's a dream for it. It's actually what we would expect, right? So drag and drop, it's there, right? Sometimes you can even be just open the editor directly on the device, although I wouldn't recommend it, because if something gets wrongly written there, you're going to lose your source code. So it's better to do it off the device and then copy it. You can write the script for it. It's fine. But unfortunately, what we did discover is while there is support for both of these processors on the CircuitPython website, what we don't have is a library for the SARA M5 modem. So that is quite a shame. There is one for communicating from normal Python, but that requires modification and a lot of testing. So unfortunately, we couldn't go with CircuitPython, not yet. I'm hoping that in the future that will change. So we had to go back to C++ and Arduino. So this is a screenshot. Let's see if we have a little bit of time. No, maybe I'm going to scroll a little bit through the Arduino editor. So one particularity of this, besides using C++, which is a little bit out of my comfort zone, but you know, you live and learn, is that the chip itself has a memory which is different than the processor. So for example, you can configure and save settings, even for example, connecting with AWS. By the way, there's 2 versions of this kit out there if you're planning on buying and playing with it. There's the Express If, specifically for AWS IoT, and this one, which is the generic version. If you're going to buy that specifically for AWS, you're not going to be able to connect to anything else. It's not going to have the necessary command. So be very, very, very careful. If you know, it depends on your use case. I went to the generic one just for flexibility, but you know, do take care. It looks exactly the same. It has the same name. You have to look at the chipset if it's the or slash firmware if it's the Express EFI AWS IoT version. So I was saying that it has a different memory, right? So you can load programs, right, separately, and you can see that in the tutorials. You can load it up, and it's basically scan for networks, select one network, and then the other is enable internet over that network. And you know, that's completely beside the point. You can then load your program that is sending data, doing some other stuff, and unless you do something else with the chip, it tries to remember things, right? It powers on with the last IP, last connection settings, which you might think is great, but it's also a little bit weird because in certain situations, if you don't have internet, which might sound weird, why wouldn't you have internet with this big of an antenna? Well, the IoT LTE-M networks don't work so well behind, you know, inside of buildings. So the use case is quite different, low power, right? So they don't penetrate as much through the buildings. So you might be in a weird, you still have to do some stuff if you want to have a steady state of a connection. So that's one thing. Your GPS chip has like a separate memory. It's like it's like you're working in a cluster and there's two different services. This is the, let's say, the service one, which also has like a control let's say a control plane, and this has its own service with its own memory and stuff. It's definitely not as easy as working with Python, right? It's not as easy because, oh boy, there's little to no examples on how to do that. And we're gonna get on that a little bit later. Like right now in this slide. So I mentioned the fact that CircuitPython didn't really have bindings for CRM5, even though it's a very popular company and ecosystem. Well, we had different surprises with the Arduino part. When we used the MQTT connection, we discovered that in the library, subscribing, unsubscribing, receiving data was all implemented, right? Some other features here and there, but sending data, that was not implemented. So what followed was a very painful you know, reminder that I haven't played with C++ in many, many years, but it wasn't such a big deal. But for maybe other people that don't have this cross-platform, let's say cross-programming language experience, it's gonna be probably a deal breaker, right? Because right now there's platforms where you can code in Node.js, in Python, whatever, .NET. It's basically an attempt for hardware to be more open and more accessible to the larger audience, right? And it shows that even with the as big as an effort we see from these providers, it's still at the beginning phase. It hasn't reached mass adoption because there are no open issues on the GitHub repositories when it comes to these libraries, right? It's pioneering. So it's instead of writing your own JavaScript libraries, maybe we should start doing some more stuff with hardware so we can help people out and make it more accessible. It's definitely not easy. It's not a straightforward experience. So let's look a little bit at the code really, really fast because I want to have some time for questions, and then we can do a small demo when we send data and we see it appearing in TimeStream, for example. Okay, so I'm gonna be pausing the share and going into more one. Zoom doesn't want to play nice with it. Okay. So we have here is a CDK project. I mentioned that it might be easier, and it actually is easier than using the console. I just have one CDK app in here, which is using the Frankfurt region, because again, I'm in Eastern Europe right now. And I have one little file. It's, well, it's 200 lines of code. So let's talk a little bit about what modules we're using. Obviously, we want an API gateway for the communication with the front end. We have a Lambda that's fetching our data. We're using IoT allocation. We're using S3 for hosting the website. And of course, we're using CloudFront as well. I am in TypeStream, and this is something really interesting, is a non-official IoT construct for CDK. So CDK, if you haven't used it, it's basically infrastructure as code. The most modern thing you can do in a cloud environment is you're using a real programming language to provision your infrastructure. And up until now, you had layer 1, which is basically the mapping with their APIs. Layer 2, which is their official libraries, which are it's like a framework, like Symfony or Spring Boot. And now a lot of libraries are starting to appear which are level 3, user created, something you would install like Foo Composer or NPM, right? So that is what we're using here right now, is creating certification certs for our device to use and send data. Used to be bash scripts or custom resources or anything like that. Right now, it's just this library that we're going to be using, right? This is the bucket. This is what we use to deploy things in our bucket from the front-end build. This is the CloudFront distribution settings. We're using React, so we want to make sure we forward those 404s. We have our database for TimeStream. We have our Lambda function. We have this little thing. This is the best. So this one little thing provisions a lot of resources in the background. It creates your IoT thing, your policy, your certificates. So that is the device certificate, the device public key, and the device private key, and it stores them in EC2 System Manager parameter store. So this one line, which used to be such a headache for people to go through all of these steps, and then, so one line. So that the power of infrastructure as code. Okay, this is our location map, which is, we have some styles in here, but that's less important. We have our GPS tracker, our places. This is just like a good thing to have. We might use it in the future. We have an unauthenticated role. We mentioned that we have to give specific credentials to it, and that's exactly what we're doing. We're just giving them, we're basically providing the permissions for the front-end app to be able to render the map, right? Because not anybody can come in and use your API to render maps. It has to be a very specific set of credentials. And this is our IoT role. This is very important. This is what takes our data coming in to those two databases, basically. So what we have over here, we're using a select, where we're sending data to the GPS topic. And for example, I've hard-coded, I know not the best thing to do, but I only have one car so far, so I could do it. We have a one car here as a device. We have the latitude and longitude and a role that we're going to be used to push things. So this is basically, we select data, we send this data to location. So this is just the basic location data. But we also send stuff for TimeStream. So in TimeStream, we have a lot more stuff. We have the latitude, longitude, acceleration on the x-axis, acceleration on the y-axis, obviously on the z-axis for those potholes. Then we have the gyroscope on the x, y, and z. So this is very important. For example, the g z-axis. So the gyroscope on the z-axis is basically gravity on planet Earth. But for the rest, it's, are we accelerating? Are we braking? Are we turning left or right? So obviously we have the speed. This is something that is also offered by the GPS chip. And that's basically, that's why we want TimeStream, right? Because we can't send, we can send some data into AWS location, but we'd have to use like a Lambda function, and we wouldn't be able to, we would have to code that. We're lazy. We don't want to code that if we don't have to. All right, so that's pretty much it. That's 200 lines of code for this first version of the fancy project. Let's see. So we would normally do, let's see, demo number 1 and 2. Let me show you something that at least a picture of the demo number 2. And while I answer some questions, while you write in the chat, I'll then showcase the other stuff as well to try and save a little bit of your time because it's almost 7. So I'm gonna pause the sharing and I'm going to share again. The Arduino. Show windows. Where are you? There you go. So this is something that I'll be able to connect in just a second. It will disconnect my camera because it uses the same port. So this is basically what is going on the device itself. And we have to be very careful because you on the device, you can take hundreds of measures a second, right? You can measure stuff very, depending on the chip. Our chip is pretty good. You can take a lot of measurements per second, but we don't really want to send a lot of data per second, right? Why? Because we have to use those special networks, and those special networks come with some special pricing models. So it's not like we have fiber at home and we can send as much data as we want. Unfortunately, that's another constraint or another special type of requirement we have, right? Data costs money in IoT. So we have to be smart in deciding how much data and how to sometimes process the data before we reach it, before we send it, right? As mentioned, we might want to stop sending data when we are at a stoplight or just parked outside a grocery store. All right, so this is how it looks. This is the acceleration, and this is X, Y, and this is the Z axis. Y, you see 1G, this is 1000 means 1G. It's basically the gravitation of planet Earth pulling you down. So sometimes as you do something like this with a device, that gravitation is felt less or more. Or as you turn things, you can see minus 1G, or you'll see plus 1G. Right. So this is acceleration. This part is the gyroscope, and this gyroscope is basically measuring rotation. It doesn't measure absolute state, it measures the rotation. So one thing that we might use this for, hopefully we'll never able to test it out in a real environment, is, for example, if your car is in an accident and it gets flipped. Well, that's an important alert to receive. So that might be interesting to have. So while I get this nice little board up and running, I would like to start receiving your questions. And for that, I will have to share my slides again, because this is a QR code that my colleagues have asked me to kindly share. So please enter this form, and while I'm asking, while I'm answering your questions, please also open a tab so you can give us a little bit of feedback so we know how to better conduct sessions 2 and 3 of this series. So I'm going to start going a little bit for the Q&A. All right. How do you ensure it is still reporting to AWS when the vehicle is switched off? So that's a very good question. It depends a lot on the power source. So when you are connected to a battery, that's pretty easy, right? I mean, you're connected to a battery. You can optimize things by using the inertial measuring unit, that the sensor that we have over here, to basically say, hey, we're not moving, go to sleep. And so it's not just go to sleep as for the device, wake up on movement. So for example, if somebody crashes into your car or you go in and start driving, you'd be able to wake up from this low power state and start sending data. Again, we might not want to send data maybe at most once per hour. Make sure that the car is still there. And we want to conserve battery. When we're connected to the car's electrical system, we have two types of circuits. We have always on circuits, which are always on, are connected directly to the battery, and engine on circuits. So that means that when the engine is powered on, you'll receive power. When it's off, you don't. If we are not careful with our power consumption and actually maybe even reading the voltage on that circuit, we can deplete the car's battery basically and cause an issue because you won't be able to start it without jumping cables. So we can make it send continuously to AWS, but we have to be really smart when and if we do that. Okay. Can we have a replay of the live? Yes, my colleagues will make sure you get some sort of access to the replay. Okay. If you were to step back and have a look at sectors of activity, i.e. retail, having accumulating much tech debt in terms of cloud adoption, do you foresee for them as options for growing, surviving in user experience? Well, especially when it comes to retail, a lot of people, since AWS was the first to pioneer this sector in a way, they've been extremely reluctant to get into it because they didn't see themselves as a customer of AWS. They saw themselves as a more of a special, different type of relationship with Amazon. So they've been lagging, as you said, quite a bit. It depends on them, right? Because a lot of them have invested in all sorts of hybrid, private stuff. It depends a lot on strategic decisions. And for me, the name of the game is how fast you can move, especially in our evolving economical situation globally. People who will be more nimble and agile will win because they'll be able to experiment faster. Usually this sort of very private cloud, maybe some sort of hybrid, is more in lines with keeping governance happy and less with time to market and experiments. So yeah, that's my take on it. Is it possible to have live tracking and alerts in the mobile phone? Yes, it is, because we don't connect directly to the device. Device sends data to the cloud. So if it sends data to the cloud, well, we can always pull data or even have a, let's say, a GraphQL subscription on it. The alerting part is something we're looking to add maybe in version, let's say in webinar free. That would be with SNS, as we discussed. Once event, so location can detect, for example, if you're going outside the area, it sends an event to EventBridge, which can then forward it to whatever you want. For us, SNS and Pinpoint would probably be the best to send a push notification to a mobile phone. So for example, your friend is speeding, it's, I don't know, 140 kilometers per hour, 150. And unfortunately, we don't really have a lot of highways. So if you're driving for 150 or more kilometers, you're definitely speeding no matter where you are. But yes, we can have live tracking. But then again, we also have to we need to understand what live means. Because for me right now, live means 2 seconds or less. It's a very, very different experience than, let's say, once per minute or once per 10 minutes. Some companies define as real time is 1 per 10 minutes. But when we talk about driving dynamics, that's not reasonable. Our next event is yet to be scheduled, so we're thinking that it's going to be in January. We also would like to do the last part on the road. We're thinking about the road show in Q1 next year. So I'm looking forward to have this device as part of the road show, and we're gonna see if at one of those events we're also gonna do the webinar. Okay. What is the name of the package you have created? Is it for sale or is it open source? So I'm using a bunch of Arduino libraries that are open source from SparkFun. That is the SparkFun. I'm just gonna open the editor right now and take a look. We're talking about the SparkFun uBlock Serif 5 Arduino library, open source. And, you know, it's there. It's even mentioned on the page, on the web page, where you can buy this device, this board. And there's another one which is the specific asset tracking library for Arduino. So there's the uBlock specific, so just the GPS chip, and then there's the whole device as a package. And the code for this is, we can publish it. I just have to clean it up a little bit because it's horrendous right now. I'm very bad at C++. So everything is open source. Okay, how would the architecture change in high-level lines if you want to cope with data coming from tens of thousands of devices, maybe more? Well, it wouldn't really change that much. Obviously, you do have service limits that you have to raise from AWS, but that's the advantage of using serverless / SaaS offerings. As long as you're in the quotas they have specified, you're great. And the quotas for IT are hundreds of thousands of devices at the same time, not tens. So that's without talking to them too much about the specific setups for you. So higher limits. We have recommended IoT services from AWS with clients before, and it wasn't necessarily for hardware. It fitted other purposes. I think that you wouldn't really have to do a lot besides the onboarding part. Obviously, what we have right now, it's a very bespoke experience when it comes to onboarding an IoT device. In a real life scenario, there's a much more complicated onboarding procedure, which starts usually at the factory, because you have to have certain things installed on the software side on the device before it gets into the customer's hand. So that's a bit more complicated. But in terms of the software architecture and the code, I mean, all things considered, it's not that big of a change, right? There's going to be some small adjustments, some new features, but you're still going to see the same boxes there. Okay, so let's go. Is there anything else on the chat still going? Okay, so there might have been a slight issue with the screen sharing. Maybe that is for the Arduino code. Let me try and see if I can do that again. It would be a shame. I hope that now people can see both the accelerometer data and the Arduino code. So I'm looking at the chat. Right. So this is what I've been talking about. This is the this is the actual, let's say, G-force of the planet pulling you down. That's 1G, and this is the other two axes where you're moving the device like this. So back and forward, or you're doing something like this. So that's what it does. And the gyroscope is basically moving. You would move a little bit when you're hard braking, or a little bit when you're hard accelerating. Well, hopefully you'll never end up like this, right? So that's something to be aware of. And these are the two libraries. So this is the first library, and this is part of the second library which we use. And this is specifically for the accelerometer. All of them are free. I mean, these are based on, let me show you some code, some more code, some example codes from the actual library. And I'm gonna stop the share and do it again. Okay, so this is one of the libraries that I mentioned. So this is the Serif 5 Arduino main library. This is from GitHub directly. You have a bunch of things in here. So as I said, even their tutorials say that you have to run number 3 first. So you get the network info. With number 4, you register with your current operator. And number 7, you configure basically your IP data, so you can send data and forward them back, which is not as easy as it might sound, because these are not using, they're using some special types of sockets. It's not like you can just go, you have internet and then you can go and ping stuff directly with the command line or anything. It's quite different than having a Raspberry Pi. So everything is open source, and hopefully on the next sessions I'll be able to push some code which will be a better quality. Okay. All right. Awesome. So what I'll do right now is I'm going to plug in the device. My webcam will go off because it's going to use the same port. And I'm going to play a little bit with it, and you can see as the numbers moving. So I'm going to stop the share. I'm going to stop the video because it's going to go bad anyway. And now I'm going to plug it in. All right. I'm going to share my okay, Arduino. All right, and this is connected. Let's go with the monitor part. I'm gonna connect again, so you can see that Sarah is connected. It started to send data. So what I'm gonna do is I'm gonna move it back and forth on an axis. So you can see me moving it back and forth. Now I'm not doing anything. I'm trying to stay still, but it's in my hand. All right, I'm moving it left and right a little bit. And now I'm going up and down to do the G sensor. So 1.6 G. And I'm also playing a little bit with the gyroscope. I'm going on all crazy sides. So obviously it's not as fun as driving the car, but it is live data. So there you have it. And maybe a sneak peek on how it would look for the actual device, the interface of the map, because I haven't presented you that. That's not something for today necessarily, but I really wanted to show you how the map style looks, because it's quite a cool map style. So I'm sharing my screen again. All right. So this is a very cool map style that when you zoom in, you can see 3D buildings and stuff, right? So this is the middle of Yash. And I have some sample data in here. These are locations that have been saved in AWS location service and in TimeStream. So this is a bunch of waypoints, and this is not very helpful for us because these are the data points every 2 seconds or so. But what will end up happening is we're going to try and build like a line with different colors and things like that to showcase the different G-forces, bigger or smaller, and acceleration and braking and stuff like that. So that's a sneak peek at next session, I guess. Let's see if there's any more questions. I see one popping up. What is the name of the asset tracker tool, and does it require a hologram SIM card or any SIM card? So it is this. Let me see. Let me pull up the video again so you can see my very tired face. it's called the SparkFun Micromode Asset Tracker. It's available. You can buy it either if you're in the US directly from them. If not, you can use some of the big Mauser, DG, and stuff like that to get it delivered pretty fast, usually in around a week. It does require a hologram SIM card. One of the difficulties you're gonna find in trying to build such a device is that most examples over the internet are over Wi-Fi, right? But you're not gonna have your home Wi-Fi wherever your car goes, so that's unusable. It does require a SIM card, and it does require a SIM card with a company which has LTE-M capabilities, and you have to be very, very careful. Usually you have a website in your country or in Europe or stuff like that where you can see what kind of networks and coverages you have. So networks, what kind of companies, and from there you look at the company and you see the global coverage map, because you're not going to have full coverage. It's like any network. You're going to have most of the area covered. And hologram is a shortcut because they have pretty much the majority of the countries out there in the world have a deal with them, and you can send data with their SIM card. However, the pricing is very different than if you would just have a SIM card for your country. Usually, if you have a very specific SIM for your country, for those type of networks, it will be much cheaper. But you might be limited or have to pay roaming. All right. So we've answered that live. Let's see. Anybody still have any questions? Is there a way I can reach you to talk more on the subject? Well, yeah, let me share the slides again and you can see my details. So hopefully you've been able to take a look and on the QR code and write some things down, some feedback for us. That will be very appreciated. But for me, particularly, if you're trying to reach me, that is my email. Well, Twitter is less used these days, but LinkedIn is, and email is something I would recommend. All right. Any other questions? Does anybody have any more questions about this session? See chat. I'm gonna go back to the QR code, give you a little bit more time looking through the chat in here. Okay, anything else in the QA? I see a new one in the QA. When is the next session? So the next session would be in January with the third session, either at the end of January or beginning of February, and the third and last session would be at the beginning of April. So, and towards the end of Q1. That's when we'll be doing the roadshow, and I hope that I can record more data and use it from the roadshow, because it's a little bit creepy showing data from where I actually go and where I live and stuff like that. So I hope that we can have a bit more dynamic driving and some more safer, privacy-aware data to share at that point. All right. Thank you very much for your time. It was a pleasure sharing with you our foray into the hardware world, and hopefully we're going to get some more interesting features and demos next time in the second session. Have a wonderful evening, and thanks for joining. Bye.